Hello guys, and then welcome to another video. Okay, so in this video we'll be talking about ordinary differential equations. Okay, ODEs. Okay, ordinary differential equations. Okay, so for ordinary differential equations, we basically focus on the first order differential. Okay, the first order differential equation. That's where we have only dy, okay, the x, okay, with other variables. Okay, so we have maybe dy dx and then y and x variables. Okay, meaning that this is the same as what y prime. Okay, so this is what we refer to as ordinary differential equation. That's only the first order. Okay, now for ordinary differential equation there are three things you need to know. Three basic things you need to know. So one, we have what? General solution. Okay, general solution. The second one is what? The standard solution. Okay, and then the standard solution. Okay, or standard form. Okay, standard form. Okay, so let me just put this in this form. Okay, let's say general form. Okay, so you have general form. Okay, and then the standard form, then we have what? The differential form. Okay, have what? The differential form. Okay, so this will be the basics. Okay, so we'll be treating general form of ordinary differential equations, standard form of ordinary differential equations, and then what? Differential form of differential equations. Okay, so this video is going to be very simple and concise. Okay, so let's dive right into what? The general form. Okay, so let's say the general form. Okay, the general form of ordinary differential equation. So okay, you might meet a certain equation like this, of this format. Okay, and then we have what? This is the same as this. Okay, and then we have what? This. Okay, y, and then what? Y prime. Okay, so let's take a look at this first. Okay, so from this you could notice that these are differential. Okay, so these are what? First derivative. Okay, first derivative. Okay, these are first derivative. Okay, the y prime is our first derivative. Okay, the x value, okay, in the equation is what? Our independent variable. Okay, independent variable. Okay, and then our y value, okay, is our what? The unknown. Okay, the unknown. Okay, yes, so this is how we represent the general form of what? Ordinary differential equation. Okay, so we have the dy dx, which is the same as the y prime, will be equal to a certain function with x, y, and y prime. Okay, so we could just omit this. Okay, and say that our general form of the differential equation, okay, has to be in this format. Okay, the general form of an ordinary differential equation has to be in this form. Okay, so we'll have a function with x, that's the independent variable, the y, that's the unknown variable. Okay, and then our what? Y prime, that's our what? First derivative. Okay, so now let's take a look at an example of what? A general form of what? A differential of an ordinary differential equation. Okay, the general form. Okay, let's see. Let's clean this one up. Right. Okay. Yes. Okay, now let's take a look at what we mean by general form of a differential equation. Okay, whenever you meet a differential equation and it's written in this format, okay, so we have maybe example, the differential equation is written in dy dx or y prime, okay, minus 5 equals 0. Okay, this is what a general form of a differential equation looks like. Okay, so you could either write it this way, okay? Let me just write it in both ways so that you don't get confused, okay? So you have example of a general form of an ordinary differential equation to be maybe dy dx minus what? 5s equals 0, okay? This is the same as y prime minus 5s equals 0. So whenever you meet any differential equation and then the differential equation is equated to 0, okay, it means that that's the general form of the ordinary differential equation, okay? The ordinary differential equation is being equated to 0. Note that every ordinary differential equation must be in its first order, okay? Must be in its first order. That's the y prime. So the same thing applies over here. So whenever you meet an ordinary differential equation and then it's being written and equated to 0, it means that the differential equation is in its what? General form, okay? So let me write another example. So whenever you meet another differential equation, something like this, okay, minus y equals 0, or this is the same as y prime minus y equals 0, okay? You can notice that both example 1 and example 2 are both written and then equated towards 0. It means that the ordinary differential equation is written in this general form, okay? Yes. Let's move on to what? The standard form of what? An ordinary differential equation, okay? Hope you understood this portion. Let's move on to the standard form, okay? Now, the standard form of a differential equation is a bit different from what? The general form of. Okay, so when we talk about standard differential equation, okay, standard form of an ordinary differential equation is being represented in this form, okay? So we have y prime, okay, to be equal to what? Okay, let me clean this one up. So we have what? Y prime to be equal to a function of x and then y. This is how we write the standard form of what? An ordinary differential equation. But for the general form of an ordinary differential equation, we got to know that it was a bit different. So let's say for this example, okay, so we have dy dx, okay, minus 5x is equal to 0, okay? So this is what? The ordinary differential equation is in what? General form. So let's try writing this in what? Standard form. So we have what? Dy dx, okay, is equal to what? 5x, right? So what this means is that whenever you make the differential or the first derivative the subject of every ordinary differential equation, it means that you've written that differential equation or ordinary differential equation in a standard form, okay? So let's take another example, okay? So in case you have something like this, okay, dy dx, okay, minus y equals what? 0. When you want to write this in this what? Standard form. So this is in this general form, okay? Since everything is equated to 0, it means that it's in this what? General form. So once you want to write this in what? Standard form, we just make the first derivative the subject, okay? So you have dy dx, okay, to be equal to what? Y, okay? And then this simplifies further to dy dx, okay, to be equal to y on x, okay? This is how you write an ordinary differential equation in what? Standard form. So let's take another example, okay? So you have what? Let's clean this one up. Right. Okay, let's move on. So you have another example. Let's say you have something like this, okay, minus y squared, okay, equals 0. Note that this is what? Yes, this in its general form, okay? And note that y prime is the same as what? Dy dx, okay? Now, this expression is in what? The general form of an ordinary differential equation. So we want to write this in what? The standard form of an ordinary differential equation. So all we need to do is just make the first derivative what? The subject. So we have what? xy prime equals what? Y squared, okay? Then we have y prime equals what? Y squared on what? X, okay? So this is what? Standard form of ordinary differential equation. And we know that y prime is the same as dy dx, okay? Yes. So this is what we mean by the standard form of an ordinary differential equation. The standard form of an ordinary differential equation is all about making the first derivative the subject, okay? Making the first derivative the subject. Now, let's move on to what? The differential form of an ordinary differential equation, okay? So, hope you understood this, okay? So, let's move on to the differential form of an ordinary differential equation. How to notice the differential form of an ordinary differential equation. Great. Now, for a differential form of an ordinary differential equation, okay, let's say this is C, okay? So, the differential form of an ordinary differential equation is represented in a different format, okay? This is how we represent the differential form of an ordinary differential equation. It's normally represented in this form, okay? So you have what? Dy dx to be equal to what? A certain m, okay, with x and y variables divided by minus n, okay, x and y variables, okay? Note that the differential form of an ordinary differential equation is similar to the general form, okay? But for the general form, we try to, group them, okay? We group only the y variables and then what? The x variables, okay? So this can be further simplified as what? Okay? Could be simplified as m of what? X, y, okay? We cross multiply, okay? Multiply this by that, we have what? X, okay? Then we have what? Multiply that by that, okay? Then we have what? Let's say we have this, okay? We have n, okay? X, y, okay? dy, okay? So we have this. So by further simplifying, that's why initially I stated that the general form of a differential equation looks like the differential form, okay? But with the dy and the x grouped, okay? So this could be further simplified to m of xy, okay, dx plus n of xy, okay, dy equals what? 0, okay? So from our initial stage, we got to know that whenever an ordinary differential equation is equated to 0, it's in this what? General form, okay? For some examples, you could be told to write certain differential equations in what? In their general form, in their standard form, and then what? In their differential form, okay? So I'll take you through some few examples and then you'll be done, okay? So this is how you write the differential form of an ordinary differential equation. This is a function, okay, with the dx, and this is also another function with the dx, right? Note that every ordinary differential equation is always represented in its differential form, okay? Whenever you meet an example problem, example question, they are always written in their what? Differential form, okay? So now let's take a look at some examples of ordinary differential equations which are written in their what? Differential form, okay? Note this is the format, okay? This is the format. You write it in a general form, but you group them in terms of their y's and then x's, okay? So let's write an example so that you get to understand it better, okay? So let's say we have this. Okay, so let's say we have what? A certain differential equation in its general form, okay? So you have dy dx minus 5x equals what? 0, okay? So we want to write this in its differential form, but it's in what? The general form, okay? So first, let's convert it to the standard form, okay? So we have what? Dy dx equals what? 5x. So we've moved from general form to standard form. Now we are going back to what? Differential form. So to write this in differential form, you could notice that we have x over here, so, and then we have what? Dx over here. So all you have to do is just write it in this format, okay? In this format, okay? So this is how it will look like. So we have dy equals what? 5x dx, okay? So we are grouping all the x's and grouping all the y's, okay? It's just like algebra, grouping like terms, okay? So differential form of ordinary differential equations is all about grouping like terms, grouping x's and grouping y's, okay? So simply we just multiply this by this and we got this, okay? Now let's move on to another example, okay? So let's say we have what? Let me clean this one up. Okay, let me clean this one up. So now let's say we have another example in this format. So x dy what the x minus y is equal to what 0. So this differential equation is in what the general form. So now we are going to convert this into what standard form. That's correct. So we have what dy dx, okay, x times dy dx equal to what y, okay, and then this will further simplify to what dy dx to be equal to what y on x. Now we want to write this in what differential form. So this is now in what standard form. So what do? We are grouping all y's and then grouping all x's, okay. So from here you can notice that we can group all x's and group all y's. So we have what multiplying dx throughout this expression, we get what dy to be equal to what y on x dx, okay. Note we are grouping like terms, so we are grouping all x's and grouping all y. So we have to bring this y over here, okay. So this will give us what, when you divide here by what y and then divide here by y, okay, divided by y, divided here by y, this will cancel that. So we have what 1 on y dy equals what 1 on x what dx, okay. Yes, so when you divide here by here, we'll get to 1 over here, okay. We don't write that one, but in case you are writing it in this differential form, this is how it will look like, okay. This is how it will look like. So let's take our last example, okay, on differential form of ordinary differential equation, and we'll call it a day, okay. Hope you understood this part, okay. So we tried writing this in general form and then converted it back to what the standard form, and then we tried grouping items. That's what differential form of ordinary differential equation is all about. Group items, group only x's and group only y's, okay, and then we arrive at this form, okay. Now let's take the third example, okay. Let's take the third example, okay. Now, so we have this, okay. Let's say we have what x y prime, okay, minus y squared equals 0. So note again, this was in their what general form of ordinary differential equation. Now you can convert this towards standard form, okay. So all we have to do is just make the y prime the subject, okay. So we have what y prime equals what y squared minus x, y squared on x rather, sorry, y squared on x. So now this in what in standard form. Now let's convert this to what differential form. Note that y prime is the same as what dy dx, okay. So we have what this y prime to what dy dx to be equal to y squared on what x. So now let's group item. That's what differential, okay. Now so once you write this in the standard form, okay, that's grouping, making the dy dx the subject, okay. That's what we mean by the standard form. Now let's convert this to the differential form, just like the previous example. So we are trying to group all x's and all y's, okay. So you can just use algebra. So you can just pause this video and then try solving it, okay. After that you come back to the the solution we will get, okay. Kindly pause the video and then try solving it to check whether you could arrive at the exact differential form of the ordinary differential equation, okay. So let's, in case you are done, let's solve this together, okay. So grouping the like terms, we have what dy, okay, to be equal to y squared on x, okay, then dx, okay. So the same thing applies over here. Just bring this one back to this point. So we divide it by y squared, divide here by y squared, so we will get what 1 on what y squared dy to be equal to what 1 on what x dx, okay. So this is what our solution will look like, okay. 1 on y squared dy equals 1 on x dx, okay. So now you can further write this in the format of what general form, okay. You can just write this in general form, okay. So all you will be doing is just writing 1 on what y squared dy minus what 1 on x ds equals what 0. Okay, this is what it will look like. Okay, so this brings us to the end of the ordinary differential introduction to ordinary differential equations. Okay, so in the next video we'll be going further into under subtopics under differential equation. Okay, under ordinary differential equation. In case you are new here, kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded videos. Share the video, like, and let me know any questions you have in the comment section below. I will just reply to them as soon as possible. Have a lively day, and then I will see you in the next video. Bye bye.